Hi, we're just going to give you a simple version of what happens when a trauma is encoded in the amygdala. So first of all, I'm going to draw a neuron in the amygdala. So this is a receiving surface of a neuron in the amygdala. There are 4 conditions that need to be met for the brain to treat something as traumatic. And we've got Emily here. E is for event with some kind of threat. It has a particular meaning. I could lose something here that I'm attached to that matters. There's a landscape to the brain, the electrochemical status, which is vulnerable in that moment. And there's a perception that there's inescapability. I can't get out of this, I can't control this, I can't influence this. When those 4 conditions are met, we have an unfolding trauma. And what happens in terms of brainwave activity when there's an unfolding trauma is that there are gamma waves, very high frequency waves, that are becoming more dominant in the brain as this is unfolding. And we measure the frequency of brain waves in hertz, and right at the highest frequency end of the scale here, gamma waves are up to 100 hertz when a trauma is encoded. What happens then within this cell, one of the key things that happens is that lots and lots of AMPA receptors come to the surface. They're a type of glutamate receptor. And we say this change in the neuron of all these receptors coming to the surface, we call that potentiation. Potentiation has occurred. All these AMPA receptors have come to the surface in much greater number. They're ready to protect the system. And there'll be an outflow. Of course, this neuron will be connected to other neurons, and the message that will be sent is get ready for getting us out of a fix. And the kinds of outflow messages really are going to be in this range: fight, or flight, or freeze, or defensive rage. And there is also some neurochemistry associated with encoding of a trauma. You may have heard of some of these, they may be familiar to you. So some of the neurochemicals for you to be aware of are cortisol. We've already mentioned that AMPA receptors are glutamate receptors. There's also a role played by dopamine. And we've also got noradrenaline. Or it's referred to also as norepinephrine. Those are the same, just 2 different names for the same thing. So that's the simple version. We'll build on this later.